Good morning, everybody. I see we've got several raised hands already, so that's a great sign. I just want to remind you to put any and all questions in the question bar. It's going to be either at the top or the bottom of your screen, depending on how your layout is. And yeah, don't bother raising your hand, to be honest. Just type your questions into that question bar, and I'll get to them either during the presentation or at the end. I'm excited to address all your questions for this one because it's definitely a really interesting topic. Today, we're going to be talking about safety and standards around lithium batteries and just batteries in general. We're even going to talk a little bit about lead acid batteries too. I'm going to go ahead and jump right in today and just want to remind you all to check out our IQ program if you're already installing our batteries. So we're going to talk a little bit more about that at the end. But we've been getting a ton of awesome applications from IQ installers all over the country and all over the world. So it's a great way to showcase your expertise with SimpliPhi products. And it takes about 5 minutes to apply if you're already installing our batteries. It's a no-brainer. All right, so before we jump into the safety aspect of this presentation, I want to briefly give you guys an overview of our company, our history, and what our goals are. So we were actually founded in 2010 as OES Energy. Now, our roots are in mobile applications. So we actually were born into the industry of making lithium batteries for Hollywood filmmakers. So something that they could carry around with them during the shoot. And this really meant that we were founded to solve a problem, and that problem was unsafe lithium batteries. Specifically in the mobile industry at that time, there were so many, thermal runaway events and just disasters with unsafe lithium chemistries. That's what we were founded to solve. And then in 2011, when we expanded into the military sector, the Department of Defense really did not even want to use lithium batteries in their applications whatsoever because of the safety concerns. However, after convincing them to just try them out and test them at Aberdeen Proving Grounds, the military did eventually agree to actually use our batteries in their projects, and they proved to be safe enough to kind of defy those concerns of unsafe lithium chemistries. So that was a big step for lithium batteries and for our company. And then we expanded into residential and emergency response sectors as well. In 2013, we began expanding our product line, always keeping the installer and customer as the focus of our products. Then in 2015 and 16, we relaunched as SimpliPhi Power. And then still to this day, we are ramping up manufacturing at our Ventura County, California facility. So all our batteries are manufactured in California, which is really unique and awesome. Something I'm very proud of as a resident of California. But we're not just in California. We actually have a global footprint spanning across 40 countries with the help of our distribution and installer network. So our batteries are installed in over 40 countries, and we got over 100 megawatt hours worldwide installed. Now, as I mentioned, we were founded to solve a problem. And that problem was initially just unsafe lithium chemistries. However, now that issue has evolved, right? Now there's a widespread limited access to safe, reliable, affordable, and sustainable power. And this is something that we've recognized is actually getting worse instead of better in a lot of places. For example, here in the US, We've been seeing electricity prices rise significantly in the past 10 years, and this is not forecasted to stop anytime soon. Utility companies are just finding more creative ways to charge us more. Time of use, peak demand. It's not looking bright for our future. And there's failing infrastructure. Now, here in California, we know that the amount of public safety power shutoffs is just going to skyrocket this year as compared to last year. And in addition, transformers and other equipment that makes up our grid infrastructure is just not designed to handle today's demands, like electric vehicles, for example. In addition, there's a growing need for decarbonization, and many cities and utilities are demanding that, they want to meet 100% clean energy goals by a certain date, but they often just don't have a super clear plan to meet those goals. So hopefully that's where we can come in with a solution. And our solution is distributed assets, providing customers with the ability to control their own power. So let's talk a little bit about chemistry, how it applies to battery safety. This is one of my favorite topics because lithium iron phosphate batteries are actually the safest lithium chemistry on the market that I know of today. There is essentially no danger of thermal runaway or fire. There are no toxic elements, and our batteries are actually landfill safe due to that lack of toxic elements. We'll talk a little bit more about this in later slides. And there's no abusive mining practices involved in our supply chain, no ventilation, no cooling equipment, and no safety monitoring equipment required. Additionally, due to the thermal stability of the lithium iron phosphate battery, it can actually operate at higher temperatures than most other lithium batteries. Now, yes, we've chosen lithium iron phosphate chemistry, but what's our form factor? Well, let's think about this. Form factor, when you talk about cylindrical form factor, that's like a AA battery, right? So great performance, incredible cycle life, durable, and short circuit protection is built in. When you look at a pouch cell, those are great for some certain applications like laptops. However, when you put them in a mobile application, for example, or a high temperature application, they're really prone to swelling and puncture. So they're less durable. And when you look at a prismatic cell, those are awesome as well, but they're a bit bulkier. So cylindrical cells allow us to pack the greatest punch in the smallest package. So now that we've kind of compared lithium chemistries and form factors, let's now jump into safety. We all want to stay safe, right? We all want the safest battery in our home possible. So one thing to be aware of when you're using a lithium battery is what's called thermal runaway. So thermal runaway is when a battery or even just one cell within a battery becomes hot enough that a chemical reaction begins. So when this chemical reaction begins, it actually consumes the materials inside the battery itself, generating more heat and just fueling that reaction. So this can cause off-gassing, it can cause fire or even explosion. This is commonly caused by cell failure due to lithium plating. Now, lithium plating happens because of contamination during manufacturing for the most part, or serious mistreatment of the battery. This can also be this can also be caused by an external heating source. So if you just light your lithium battery on fire, yes, it's going to go into thermal runaway. Or if there's an internal short circuit within the battery, maybe it's been punctured with a nail or a screw, or maybe it's even been overcharged. So anything that's going to increase the temperature of the battery enough to set that reaction off, it's going to then become self-sustaining. And as you notice, I've got a bunch of links in this presentation. I will have these links in the description of the recording of this video on YouTube. So in addition to just the thermal component of thermal runaway, just heat being generated, there's also gas being generated, which is a concern because this gas is toxic and flammable if it escapes the battery. So luckily for, cylindrical cells are actually made of steel. They can hold, gas in a bit longer than some other form factors. If that gas is held within the cell, nothing's really going to happen. If the gas escapes the cell, like I said, it is toxic and it is flammable. Now, on the bright side, lithium iron phosphate can reach a much higher temperature than other lithium batteries, other cobalt-based lithium batteries before thermal runaway begins. Now, the presence of cobalt in the battery is really what makes it so thermally unstable. Cobalt is very energy dense, but when it gets to a certain temperature, it can create a disaster. Now, as you see, lithium iron phosphate can reach 200 Celsius, whereas an NMC can only reach 170 Celsius before thermal runaway is going to begin. And then in addition, after thermal runaway starts, lithium iron phosphate would only reach a maximum temperature of around 400 Celsius, whereas NMC is going to reach a much higher temperature of around 675 Celsius. So the main aspect that causes thermal runaway to propagate, which means spread from one cell to another cell within the battery, that's the amount of heat it gives off over time. So as we can see, lithium cobalt oxide is one of the highest, heat rate. It releases one of the highest heat rates of all the lithium batteries. So then we can see nickel cobalt aluminum batteries in blue, and then nickel manganese excuse me, I always mess that one up. Nickel manganese cobalt batteries in red. Now, when we want to see the amount of heat actually released by a lithium iron phosphate battery, we have to zoom in 100 times just to even see the little blip on the radar that is lithium iron phosphate. So this is why heat does not often propagate from one cell to another, meaning the thermal runaway really just does not often spread in a lithium iron phosphate battery. If by some crazy chances there is a thermal runaway event, it is very, very likely that it is contained to one cell within the battery. Now, let's talk about other batteries that are not lithium iron phosphate. Because they are thermally unstable, they need added equipment such as thermal monitoring equipment, thermistors, for example, ventilation, so you need a fan within your battery setup, and a cooling equipment. So it's often there's a liquid cooling system with a pump that is going to pump coolant. Now these three components are very cool looking on this DIY lithium battery that I found on YouTube, and they certainly make it look robust, and I'm not picking on this battery at all. I think it's a very cool project that this person has built. But think of all these added points of failure, right? What happens when your car's your car's radiator, the radiator pump fails? Your car overheats instantly. What do you think is going to happen here? So I don't want to have these devices relied upon to keep my home safe or my battery at a stable temperature. I think that should be more built into the chemistry of the battery, in my opinion. This is why our batteries do not need this, is because lithium iron phosphate is just a more stable chemistry to begin with. So when we compare lithium batteries to lead acid, which is something I promised we would talk about today, lead acid it can experience what some people call thermal runaway during charging, but this is not a really heat releasing reaction for the most part. So this would be, let's say your lead acid battery is on the charger, and that charger is kind of a older, unregulated charger, and the lead acid battery's temperature increases. The resistance of the battery will decrease and it will accept more charge current. That extra charge current is going to heat up the battery more, and then the cycle is just going to continue. So ultimately, this ends when the electrolyte is burned off around 125 degrees Celsius, which is not too far above boiling temperature of water. So nothing crazy here, but the danger is that gas is released during this process. Excuse me. Now, hydrogen is produced even during regular charging of a lead acid battery, but during overcharging, hydrogen sulfide is produced. Now, both hydrogen and hydrogen sulfide are explosive if not vented. As you can see here, this setup was not, these two setups were not vented properly. It actually caused an explosion within the battery room because of a buildup of hydrogen. So when we talk about safety of a lithium battery here at SimpliPhi, we actually want to consider the whole lifespan of the battery from, before it's even produced to after it's thrown away. So a lot of people think of lithium mining as some crazy operation. It's really not. It's actually mostly environmentally benign. And this is something that I'm really personally concerned about and always have looked into before choosing my products personally. And so it's good to know that lithium mining does not involve, underpaid workers going into a dark tunnel with a headlamp and a pickaxe and, gathering minerals. It actually is much easier than that. Water is pumped through an underground salt bed. Those salts and minerals are carried up to the above ground salt bed that you see in the top photo. The water evaporates and it leaves behind the minerals and salts, which are then used to make the liquid electrolyte. Now, lithium, iron, and phosphorus, the three main components of our batteries, are abundant. They are not limited in their production capacity. They're not hard to find, and you don't need to rely on child labor to produce them, unlike a cobalt. Cobalt comes primarily from the Dominican Republic of Congo. This is mainly highly mechanized plants, but there's still a large portion of these plants that are just people digging with hand tools and with their hands, literally. So not only is there a ton of black market cobalt coming from the DR of Congo, but there's also a huge lack of regulation in the quote unquote regulated mining operations because of the corruption from political leaders. So as you can see, in these photos I pulled off of a YouTube video, ultimately, this is just somebody mining in maybe even their own backyard. They're saying, be careful, go slowly, it could collapse on top of you. And really their operation is not very sophisticated. They're not wearing any helmets. They don't have any safety tools. And this is really a flattering image, I'll say, compared to most cobalt mining operations. So now that we've talked about battery safety, let's talk about the standards that ensure that safety. For example, the ability to FAA to the ability to airship a battery that comes from the FAA approval, which is dependent on your 3480 and 38.3 UN tests. So 3480 is packaging. It's pretty boring. You're going to see the label on your packaging. I'm not going to talk too much about that. It's just packaging. But note that you should keep your original packaging for your batteries in case for whatever reason they need to be transported. So the reason that we need 38.3 is because of the over 200 incidents that have occurred in airlines that involve combustion of lithium batteries. So for example, if you had a Samsung Galaxy Note 7, I actually had this phone and was not allowed to fly with it because there were so many events where it simply like caught fire or melted within the user's pocket. So we have gone through extensive testing to actually receive permission to airship globally. And I'm going to tell you what that entails. So the UN 38.3 test, this involves some really rigorous testing. So first they're going to store the batteries at low pressure and simulate high altitude. Next, they're going to do some thermal cycling, very cold and hot cycling in rapid succession. Then 36 hours of intense vibration, followed by 18 simulated drops or shocks. So this would be simulating like an automobile or plane crash. Now, to pass this test, they're not exactly testing for operation of the battery, so to say. They're not going to check capacity necessarily, but they are going to test that there's been no leakage, venting, disassembly, rupture, fire, and no significant change in open circuit voltage. This really means that, they're making sure there's been no disasters and no major change to the layout of the battery. So nothing's become disconnected or short-circuited within the battery during this time. And again, same with the two additional tests, a short circuit and overcharging tests. They're going to make sure, no fire happens during this, and it does not exceed a certain temperature. So these tests are not something that I'm going to recommend you do at home, of course, not even necessarily things that our warranty is going to cover. However, it does make me feel awfully safe using our batteries at home. Now, UL listings are something you're going to care a lot more about. Now, UN is for shipping, right? So we have to care about the UN listings or the UN certifications so that you don't. But the UL certifications and listings, these are something that you're going to need to understand if you're an installer. The 1642 is a cell level certification. 1973, this is a module level, and 9540, it's kind of a whole system level. So it actually evaluates the inverter and battery, for example, making sure that they're compatible together. A newer test protocol is the 9540A test. This is not a certification and it does not affect the other certifications, but it is something that we're going to talk about. UL certifications are needed for mainly residential systems, something that you're going to need to obtain a permit for, or something that's going to be inspected. So if you're getting your system inspected, they're almost definitely going to require a 1973 certification. And as time goes on, more and more jurisdictions are also requiring 9540 and some even 9540A testing. It is a little bit different everywhere you are. However, in general, you should always check with your authority having jurisdiction and make sure you strike up a conversation with them and understand exactly what they're going to require. Even if you're not required to use batteries that are UL listed, it's still good practice. Think about insurance purposes. If anything does happen to your property and your insurance company comes to check out what batteries you were using and they were some random DIY battery, they're going to be scratching their heads. Even off-grid properties, those are going to be inspected at the time of the sale, and they still need to meet the building codes and fire codes in that area. So when we break down the different listings, again, 1642, this is really a cell level test, or excuse me, cell level certification. It does involve testing, which is very similar to the UN 38.3 testing. Again, it's, shock, vibration, drop, all these intense, rigorous tests that are going to try to force the cell into thermal runaway. Now, 1973, this is building on the 1642 and evaluating the characteristics of the module, the battery module itself. So the battery's ability to withstand abuse with and without the BMS safety features intact. Now, 9540, this is less of a test and more of a evaluation of the prior data for the most part. It's going to evaluate 1642, 1973, as well as the inverters UL listing and make sure that they're compatible when operated together. We have finished testing for access and boss configurations. So there's a ton of options there now that are UL 9540 approved. So if you need help with navigating your jurisdiction's requirements, we're happy to assist you there. Now, something that's newer, but increasingly being required, because as I said, 1973 is required by most jurisdictions, if not all, and 9540 is increasingly being required by more and more. California and New York are kind of leading that charge. Now we see 9540A. Now this is new, up and coming. It is not a certification, it is a test method. So this is going to seriously light batteries on fire. It's going to see how they react to being pushed and forced into the thermal runaway, and evaluate the safety features at mitigating thermal runaway, and also just see what occurs when those safety features are bypassed as well. So again, this does not affect 9540. It's separate right now. It does not affect the first edition of UL 9540 or UL 1973. It's just a test, not a certification. New York City is probably the most pertinent place when it comes to requiring 9540A test reports. But again, this is going to increase. The list of places is only growing. Now we've talked about UN and UL listings. Let's also talk about the disposal standards. So when we talk about disposal, we're really talking about RoHS compliancy. RoHS compliancy is mainly just requiring that your device or thing that you're disposing, it cannot contain any toxic chemicals such as heavy metals. This actually is not related to cobalt. So surprisingly to me, cobalt can actually be disposed of in some places. But I think that this is going to cause a lot of issues. As you can see in this recycling plant in Cincinnati, there's been 6 fires since 2016 due to this improper disposal of lithium batteries. So whatever you do, if you do end up disposing of a lithium battery, make sure you look into what you're allowed to do in your, in your county and city, and probably going to end up taking these to some sort of a hazardous waste center or ideally a recycling plant. Now that we've kind of talked about all these certifications, I do want to talk about safety during installation. Excuse me for just one moment. I'm going to just check on the questions here, make sure nobody's pointed out that my audio or video are down or something like that. Okay. Thanks for the great questions, guys. Going to get to those really shortly here. So before you even install your batteries, I want to suggest that the safest thing you can do is hire a professional, somebody who does this for a living. They are up to date on all the codes and requirements in their area, and they know how to safely complete and plan an installation. Now, as I'm talking to you professional installers out there, you already likely know all the requirements for wire sizing, breakers, and fuses in your area. I want to briefly show you a really awesome tool, though, that I have found that helps me design especially DC circuits, as I know the requirements for AC circuit wiring sizes and breakers are very easy to find. Personally, I've had a harder time finding DC circuit fuse and breaker sizing as well as wire sizing. So I want to run through this awesome tool that Blue Sea offers. This is part of their circuit wizard. They actually have a awesome chart that shows you for whatever current flow you have, what wire size you need to use. And always we're going to recommend less than 3% voltage drop every time. So once you've chosen your wire size, you can also go to part 2 and select a fuse size if you're going to use a fuse. You can also use a breaker, of course, for overcurrent protection. But let's say you've picked an ANL fuse. I've used a bunch of these in camper vans and such. There's tons of equipment for them. May or may not be the right thing for your installation. But let's just say you picked an ANL fuse and you want to see how long it's going to take to pop. Because a common misconception is that, okay, let's say I've got 2 batteries and they're rated to 37.5 amps each. That's 75 amps. I want a 75 amp fuse. It's not always correct. If you're using a 75 amp fuse that doesn't blow until it's got about 140% of its rated current, then that 75 amp fuse is not going to blow until you've reached 105 amps. So that's not adequate protection. Now, if you wanted to make sure the fuse blew at approximately 75 amps, you could divide 75 by 1.4, which is for 140%. Get about 53 amps. So 50 amp fuse would be adequate protection. So that's why this isn't always as straightforward as just picking a 75 amp fuse when you want to limit current to 75 amps. Always look at these delay curves, and not every company has these for their equipment. Luckily, Blue Sea has a ton of them, and I find this really helpful. We've also got a bunch of tools to help you with sizing your battery portion of your system. Those are on our website. You can check them out here. Again, these links are going to be in the description of this recording. Everybody who's signed up is going to get a copy of the recording, so you'll all have access to these links. Now, when you're sizing your battery portion of your system, the most important thing to follow, among other things, is the C/2 rule. So if you've got a 8,000 watt inverter, you need a minimum of 16 kilowatt hours of storage. So 8 kilowatt inverter, 16 kilowatt hours of storage. Just multiply by 2. So that means you need 5 batteries for an 8 kW inverter. The reason for this is because our batteries can discharge at C/2, meaning you can charge and discharge them fully in 2 hours. So if you've got a single 3.8 kilowatt hour battery, you can discharge that at 1.9 kilowatts continuously. Now, there's other considerations, of course, that go into planning and installation, but I don't want to go too in depth in this video. We have several other videos about that. But one other thing I want to point out briefly is that look at the detail of this wiring diagram. Now, I've actually pulled this off of one of our installation guides, so we do some of the work for you. However, your installation is likely going to differ at least somewhat from ours. So what I encourage everybody to do is make a single line diagram and then also make a 3-line diagram or 2-line, whatever suits your application, and actually show each connection, right? So make sure you're not forgetting how many lugs you need. For example, this and the terminal post sizing, how many lugs you can land on one terminal block. All those are important, and those details are kind of going to be missed in some single line diagrams. Another tip when installing batteries, make sure you have the proper PPE. Really, for any battery installation, you're going to want coated gloves, a dry environment, insulated tools so you're not zapping yourself as you're tightening a lug, calibrated torque wrench so you don't over torque the batteries, voltmeter and amp clamp, and any various electrical tools. But also, when installing a lead acid battery, you're going to want to make sure you've got PPE like a thick apron, some boots, and I like to wear long sleeves, long pants. You're going to want acid resistant gloves and a face shield and goggles as well, in addition to a spill kit. This is because lead acid electrolyte is actually toxic, and it tends to just get everywhere when you're filling the batteries and checking their specific gravity. Once you have finished all of the wiring for your system, here's a good guide you can use for commissioning, the order of commissioning. What should I connect to what first? First off, make sure your breaker is off during installation until you're ready to fully commission the system, and be careful not to short the terminals while you've got the breakers on. Never connect 2 batteries at a significantly different state of charge. This is going to result in not a good balance between the batteries during operation, and then also a rush of current from one to the other. This is especially a concern when you're adding a battery to an existing bank. So when you're adding a battery, you want to make sure you charge up the existing bank fully, disconnect it, then connect that new battery to the charger, charge it up fully, and then you can connect it to. So for order of commissioning, once you've got everything installed, you want to first turn on the battery breaker and connect it to the DC bus bar. Next, you're going to connect the charge controller to the charging source and let the batteries charge up fully before turning on the inverter and loads. Alternatively, if you do not have a charge controller and you're charging the batteries from the grid, you will have a loads breaker and an input breaker. So you'll want to have the batteries on, that'll turn the inverter on, and then you can turn on initiate a charge by connecting the AC in, but do not turn on the loads breaker until the batteries are fully charged. This is because the batteries do not ship fully charged. They're not allowed to. They ship at about 20 to 30% state of charge due to regulations around transportation. So last but not least, Before we jump into the FAQ section, I want to also point out that if you are already installing our batteries, you should apply to our IQ program. It takes about 5 minutes, and this is ultimately going to result in a whole lot more exposure for you and your company. And this IQ, this where to buy map, this is where we send, anyone looking for an installer or distributor in their area. So if you're installing your batteries and you want to appear on this map, it takes about 5 minutes to apply. Just submit a couple photos of your installations, and there's a very short quiz, and we'll get you through the program in no time so that we can advertise for you, essentially. What we do is when you're added, we're able to give you a shout out on our IQ newsletter, and the installers on these newsletters are actually getting quite a few clicks. We've been seeing that that's been the center of attention on these newsletters. So if you are already installing our batteries, give me a shout. Alrighty. Well, thank you everybody for coming. I'm going to now jump into the FAQ. Blue Sea products don't look to be UL listed. That is a good point. I honestly did not even consider that. Make sure you're using UL listed components for all of the portions of your installation if they're going to be inspected. Otherwise, if you have a relationship with the inspector or the AHJ, you can get in touch with them and see if that's going to be a big deal for them. Can the original packaging be stored disassembled, or how much space is needed to store the packaging? You can collapse it and store it however you want. Just don't, rip a giant hole in it and then try to reuse it. But yeah, you can store it disassembled. If I try to verify the 1642 certification of the battery by, for example, crushing it in my backyard with a bobcat, am I still eligible for a refund under my 10-year warranty as long as I hold on to the original packaging? Unfortunately not. I'd say, it's probably safe to use your batteries as a couple of bicep curls. That's probably covered by warranty, but I would not suggest crushing it with a bobcat. No, that would definitely void your warranty. Good question. Can you compare and contrast issues discussed today for the Tesla Powerwall with the SimpliPhi comparable? So the Tesla Powerwall is not lithium iron phosphate. It is a cobalt-based chemistry. So ultimately, there is a concern of thermal runaway. In addition, I know our warranty is the best in the industry. It's the longest lasting. So that is another concern. If you're looking for cost per kilowatt hour, I'd suggest checking out our calculator, and you can go through the cost per kilowatt hour of both options. I'm pretty sure you'll find that ours is quite a bit less cost per kilowatt hour. My building official is insisting on a 9540 UL listing, and I can't find it on any of your tech sheets. Yeah, just email my email rate. Oh, my email did not appear there, did it? Let's see. Okay, yeah, so you can just email me and I will send you over to our sales team. Alternatively, you can email sales@simpliphipower.com. They will gladly create a solution for you that is 9540 listed. They can pair inverters with batteries that they know have been UL approved. So I believe we are UL listed for several different solutions with our access units and boss cabinets. So there's many configurations you can make with those cabinets, both indoors and outdoors. Okay, we're charging almost exclusively with solar, 4.4 kilowatts through 2 Outback charge controllers. Using both your Outback and Midnight charge controller settings, we're not sure which absorb voltage to use. Well, it depends. Are you using an Outback charge controller or a Midnight charge controller? For the Midnight charge controller, use the Midnight integration guide. It's going to show you a 56 volt absorption voltage. For the Outback integration guide, the Outback charge controllers, we recommend 56.4 volts most commonly. The reason for that is if you've got an Outback charge controller, an Outback inverter, then the absorb voltage on the charge controller, you want to be slightly higher than the inverter. This signals to the inverter to prioritize PV charging when available. So I would go with 56.4 volts from an Outback charge controller if you've also got an Outback inverter. That's for the 48 volt battery. If you've got the 24 volt battery, cut that in half. Will SimpliPhi get involved with electric vehicle charging hubs? Good question. I mean, our batteries could definitely be used for that. So if you are looking at designing an EV charging port with some energy storage, SimpliPhi batteries would be a great fit. Does SimpliPhi take back EOL batteries? So that means end of life battery. I think what you're asking is, at the end of the life, when you want to get rid of the battery, can you ship it to us? I think that's a question that we're currently evaluating on a case-by-case basis. I'd say don't hesitate to email us, but for the most part, we would prefer to see you either recycle it or take it to a facility near you that's meant for recycling or disposing of lithium batteries. So we're working on something that would be a better solution for the future, but right now it's a little bit difficult. There's definitely a lot of movement happening in the lithium battery recycling industry, so we're hoping that that moves quickly. So we got a question here. Is there a certification for using batteries in mobile applications specifically? Not that I know of. You know, I don't think there's a specific UL listing for that. I'm not sure. However, during the UL 1642 as well as the UN 38.3 listings, there's some really intense vibration testing as well as shock testing for, like, crashes that is undergone during those. So I would say that that testing is essentially already done. It definitely makes me feel safe knowing how intense that testing is and that there's never been any issues with that. Let's see. I'm just trying to see if I missed any questions. We've still got a few minutes here if you have any last minute questions. To maximize longevity, should I use your 3.8 battery in a range that stays between 20% SOC and 90% SOC? Or is there no harm in going to 100% SOC with your 3.8? That is a great question. You should feel free to go to 100% state of charge. There's no harm in going that extra 10%. Actually, I would recommend you charge to 100% SOC, at least on occasion. What that's going to do is allow your battery to balance, because at the top of the charge cycle is when the cells balance out. There's passive balancing at the top of each charge cycle. So going to that 100% SOC is really going to ensure that you're getting the full capacity each charge cycle and discharge cycle. Whereas if you stay between 20% and 90%, you really are not elongating the life of the battery, in my opinion. I would say going to 100% and down to 20 is the perfect use. If you're going from 100 to 50%, that's fine as well, but I don't see any benefit in not fully charging your battery. Excuse me. If voltage is not always an accurate indicator of state of charge, then when I add a newer battery to an older system, will those voltage readings ever sync up? So ultimately, when you add a new battery to an old system, you want to make sure that you first charge the existing system fully and then separately charge the new battery fully before combining them. When you do that, they'll be at the same state of charge and a very similar voltage. Now with lithium batteries, if they're off by half a volt or so, but they're full, so this charge curve is going to be very flat in the middle, and then at the end, it's going to be very steep. So half a volt difference on the higher end of the charge cycle is going to be a very minimal difference in state of charge. So even if those voltage readings are just a little bit off, when you do, connect them in parallel, it's more important that they're both at a similar state of charge. So if you have any questions when commissioning your system, definitely feel free to give us a call on our tech support line or an email, and we'd be happy to walk you through that. Awesome. Well, I don't see any more questions, and I just want to thank everybody for joining. Hopefully you learned something about not only lithium battery safety, but also the standards that are important and applicable for your specific installation. And again, feel free to contact me or training at SimpliPhi Power, or even sales at SimpliPhi Power if you need a system setup or a UL 9540 setup. If you need assistance with any of that stuff, don't hesitate to reach out. Have a great rest of your day.